Ah, yes, the good old 2010 Beverage Toasty. Who actually remembers that originally from the original upload? I used to do random videos like that when I had spare time. When I had free time, I used to kind of do funky, weird shit like that when I was bored. Because I was like, yeah, I want to make a sandwich. This sandwich is going to be epic. Let's film that shit. So today, guys, we have on the bench a very well-respected amplifier amongst many people in the audio scene. This is the DC Audio, not level 5, sorry. This is the DC Audio 5K, 5.0K. Many will claim this amplifier to do well over rated power and also continue to do good power down into 0.5 ohms and into high input voltage, like I think 18 volts and that sort of thing. However, at the moment this amplifier does 0 watts RMS because it's smoked up, let out the magic stank, and we need to put it back in. So, how's everyone going in the live chat? We've got Jesse bang on the stream. Now this is a much earlier stream than usual. I decided to do a stream during the day so I can catch some of my my followers from Europe, maybe other people around the world who maybe can't catch me in the evenings when I live stream here, and it tends to be afternoon in the US, but other places in the world maybe it's the middle of the night. So I thought I'd do an earlier stream today. So yeah, I've got Jesse jumping on the stream, and a few other people. Mr. Am007, what's up, my man? Aaron, what's going on, buddy? Oh yes, this is the thing. Aaron, he's not at work, so yeah, I want to try and do live streams at different times of day, try and catch different people. So you actually get to see something go down live rather than watching it back later on. So, as with any amplifier when it first comes in, now interestingly, I was talking to a very good friend of mine, Giant, who you might heard me mention his name on the stream many a time. So Giant has been watching my live streams for a long time, since I started doing them pretty much, and Giant hasn't experimented in amplifier repair himself yet, but he's watched all of my streams. And so I was talking to him about Amplifier, and I was saying, you know, I think he sent me something, or we were talking about some repairs, and I was saying, oh, dude, you know, you like, have you ever thought about like buying a couple of blown amps yourself and seeing if you can fix them? And he said that although he's watched a lot of my streams, he wouldn't necessarily, like, the information kind of is cool to watch and stuff, but doesn't necessarily retain it unless it's actually there doing it. So what I thought would be cool to do is go right from the start on this amplifier repair. I'll talk through everything that I do, everything that all my thought process is going forward into diagnosing the issue and making the repair. So, what's up from the USA? How's it going, my man? Diagnostic analysis. Remember that video? Cool. I'm glad you guys enjoy. I'm going to try and mix up the intros a little bit, make it kind of interesting. So we had the hair trick loop with the random background music, and then we've got the toasty video. So I'll try and think of some cool intros. I think I'll have funny things to do. So the first thing to do when you get the amplifier on the bench is to select the correct camera for your live streamers, and I think the correct camera for this is going to be the head cam. So the first thing we do when we get the amplifier on the bench is determine how much of this thing has blown. I'm going to try and sit very still because I know sometimes the head cam is a little bit wobbly, and I'm also just going to remove my scope from the screen. That makes it a little bit easier for you guys to see. So the amplifier comes in two halves. You have the half which supplies power to the amplifier, the power supply. This is like one separate circuit entirely, pretty much. And then this side is the side that actually makes audio, that takes the rail voltage, turns it into the sound as per whatever the input signal is, and sends it out the speaker outputs. These two bits of the board may as well be in entirely different cases to each other. They are completely separate from each other in terms of, like, you know, what they do, and they have separate protection circuits, they have separate drive circuits. It's all they're pretty much completely separate in terms of what they're doing here. So in order to work out how much of this crap is damaged, start off with the power supply, because the power supply is the first thing that's going to power up when we plug it into our bench supply. So we don't want to kill our bench supply, we don't want to cause any further damage. So we're going to take our multimeter, put it onto continuity setting, which is usually the little diode symbol here. If you don't have a diode symbol, you can put it onto the lowest resistance setting, which is usually 200 ohms. But mine has a diode setting, and it usually beeps when you have continuity. So if the power supply blows, most times you end up with a direct short across your battery terminals, which is why you get a bunch of smoke, because if you've got a direct short across your battery terminals, then obviously your batteries are capable of supplying loads of current. So whatever it is that's shorted inside here that's causing the short across these is going to cook up and get super hot and let out all the smoke. So do we have a short circuit across our power terminals? That is the first test to always make. Yes! We have pretty much a short circuit across our power terminals. So we have 3 ohms across our power terminals. Not good. So we have a blown power supply section first and foremost, and you can tell that just literally by doing that. Uh-oh, power supply has gone down. Now, power supplies don't often die of their own accord. It does happen, but it's less common. Usually if the power supply is dead, then it also means that the output section is bad as well. Now, you can't do the same thing with the output section as you do with the power supply. You can't go ahead and go to the speaker terminals and check for continuity across those. And the reason you can't do that is mostly because you have these relays which isolate the speaker terminals over here from the amplifier's output section. So you can't really check for short across it like that. And also the circuit works in different ways. The way to check whether you have a dead output section quickly without having to remove anything really is to measure across the the rail voltage to the ground. So these are the rail capacitors. The rail capacitors store the high voltage that the amplifier needs to work and make power. Usually if the output MOSFETs have shorted, then they will short between the rail and ground. They have the rail voltage on them and they have ground on another pin. And if it shorts between the 2 pins, then we can quite easily see that. If we check on the board here, most of these kind of Korean style half bridge monos have these bars here. And these are usually labeled up as resistors. We've got R259. And what these are very low ohm resistors. And these are to do with the protection circuit. They are current sensing resistors. So there'll be a circuit that detects the voltage drop across these resistors. And if the voltage drop across these is too great, meaning that high current is passing through these resistors, then it shuts the amplifier down. So these bars will have the rail voltage on them. So if we put one probe on these bars and another probe, I think we can put it on the RCA ring, because that is output section ground. So we have rail voltage and ground, and I think we might see some continuity here. Okay, so the capacitors are actually charging here. So we've got 302 ohms on there, which is kind of low. That's not that great. So that rail potentially might be okay. Let's check the other rail over this side. Okay, that one may potentially be okay as well. Maybe that's not the way I usually do it, but I thought that might be a cool way to see whether the output section was blown without having to remove any of the clips. The best way to check if the output section is blown is just to remove the clips like I usually do. I was trying to be clever, and I hadn't actually tested that yet, but I don't actually know if this amplifier has got a blown output section yet or not anyway. Oh yes, and the best, well, I mean, if you haven't got the time or the patience to make a special tool to remove these clips, literally you just need to get an Allen key that is just big enough to go into these little holes here. You don't want it too small, you want it as thick as you can get it so that it's nice and tight in the hole. That's what she said. And then take some pliers for a bit of leverage, and literally it's super easy. They just come off like so. A lot of people, like, I've had quite a few people ask me, like, how the bloody hell did you get these clips off? They're a pain in the arse. And yeah, I agree, they are a massive pain in the arse. I hate them, but if you've got a few bits and pieces laying around the workbench, then they're not that difficult to get off. I might as well go ahead and take all of these off, because we need to take the amplifier out of the case to do the repair. So whilst I'm taking those off, what's going on in the live chat? It's about the box as an intro song. It says The Lennox. Oh man. That song is embarrassing. I'm not sure if I can put that one as my as my intro song. Maybe. We'll see. So the power supply ones. Now this amplifier, DC 5K, is very, very similar to the Sundown boards. Actually, it's exactly the flipping same. So DC 5K is pretty much the exact same circuit as the Sundown, one of the Sundown 5Ks. So it's using IRF 3205 TO220 MOSFETs in the power supply, and it's using lots of those. And the output section, I imagine this is using 24N40F outputs. Let's have a quick little peek here. Yeah, 24N40F. You guys probably won't be able to read that, but those output FETs are 24N40F, which are very, very common. I have usually have quite a good stock of those in my drawer here. So very generic, very basic, old school circuit design amplifier that tends to be pretty reliable, and yeah, you can pretty much abuse these circuits, and as long as they're built correctly and they don't suffer from vibration damage, they don't tend to blow particularly often. The only clips which are a pain in the arse to get out, and even with the Allen key, are the ones which are right next to the capacitors, because you don't really get any leverage room. You just kind of have to go at an angle and... Oh damn! And snap your Allen key! Oh shit! That's never happened before. These Allen keys are usually extremely strong. That one must have just given up the ghost. Okay, well that's annoying. maybe it's a good idea to make a custom tool in the end anyway. Okay, so that one's dead now. Do I have another Allen key that fits in there? I may have to go to my toolbox outside and get another Allen key to fit in there. That's very annoying. RIP Allen key. Not chromium vandalum alloy maybe. Those are harder to break. You see, that Allen key that I was just using that just broke was my kind of go-to Allen key that never broke when I was doing these clips. That was my kind of superior Allen key that always was a survivor. This one, as you can see, this Allen key here that I was using before for some time is super duper bent now. Now Allen keys don't usually like to bend. They usually just snap because they're very brittle. So I'm going to see wherever I can get it off with this, but I think this clip is incredibly tight. I think I'm going to end up breaking this Allen key as well. So you may have to venture out to the toolbox and get another Allen key that's the right size. Okay, now that's just going to break this Allen key as well. God damn it! BRB then, I need to go and get another Allen key. Okay, hopefully one of these guys will fit. Do you know the brand Fidec, which sells PA amps? I'm not familiar with that brand. Sorry, buddy. Sam, what causes protector light to come on and stay on? Please help, I want my bass back, says Jose. If your protector light is on and it stays on, it probably means that you have a shorted output MOSFET, and it means the amplifier needs repair, needs a proper service, needs the MOSFETs replaced, and possibly also the drive circuit. There is no easy way to get the amplifier out of protect. It's protecting because it detects that there is a problem. The problem is usually an output failure. There we go. I've got a nice big Allen key as a replacement here. So hopefully, if I take it slow, it should be alright. Just gotta take a quick phone call. This is the problem with doing these live streams during the day. I get constant phone calls. Okay, sorry about that. Yeah, there might be a few bits of that. That's the thing. When I do the live streams during the day like this, all sorts of phone calls going on. So yeah, I finally got those clips off. I have now bad boy Allen key that shouldn't fail me going forward. Fine nose pliers is supposed to do the trick. The fine nose pliers don't get under you. There's no leverage underneath the fine nose pliers. My audio is dead, caused by the wrong base controller. All the MOSFETs are fine, yet I have no sound. If I put my RCA in the bridge side RCA output, then sound goes. What can the problem be? So Matthew Ashley, the problem is because you put the wrong remote controller in the amplifier, then what's happened is it's probably sent like 5 volts DC or maybe 12 volts DC to some of the op-amp chips in the amplifier that are dealing with the regular path of the audio. So if you look in the amplifier, so look, here we go, I can show you something similar here. So to help out Matthew Ashley on the live chat here, so you have your RCA input here, okay? When you put it in the bridge mode or the slave mode slot, then it bypasses all of this circuit here. It bypasses the majority of this circuit and sends the audio directly into the driver board, which is what's going in here. However, obviously normally, under normal operation, you're plugging it into the regular RCA input with the left and right input. And so what's probably happened is you've probably killed one of these type of chips over here. So it'll be a TL074C or a TL072C or a 4558. So these op-amp chips here, you need to probably go ahead and replace those. If you have a workbench with an oscilloscope, then you need to take the amplifier, power it up on the bench, run some audio into the RCAs, and then with your oscilloscope, follow the audio through the amp and find where it loses it. You know, which chip doesn't have audio coming out of it, for example, if you know what the pins on the chips do. If you're not sure, try replacing all of those chips, 072C, 074C or 4558 chips or similar in this input section of your amplifier, just this tiny little section near the RCAs, and it might start working again, because the chips are the most common thing to die if they get hit with DC on the audio signal line. So give that a go first. Did you get your subs today? I got my subs last week. They're in the van, and I'm in the process currently of making a video on that. So I made a video of installing the subs and picking them up, and I'm going to be doing some demo videos shortly with them. They're very, very stiff. At the moment, they're not like extravagantly louder than the 35s, because they're extremely stiff, and because the amplifier is nowhere near enough power to run them properly. I've got a 4.5K, so each Z is currently getting 2.2K before rise, and because the impedance rise is so great, I don't think those 15s are even barely getting 1,000 watts. I would be very surprised if each of those 15s is getting more than like 800 watts. So I need much more power, and I need to let them break in. So I'm currently doing a video of them breaking in, and then I've got another LW audio that I'm going to strap at 0.25 per amplifier, which should give me a lot more power after the impedance rise. So I'm going to do that and video that, and then release it probably in a few weeks' time. Can you have a look over the circuit? I'm not so good with PA amplifier circuits, man. I probably wouldn't be too much help for that. The first time I see the vape connected to a battery, yeah. Yeah, usually it's connected to the power supply. So yeah, all these amplifiers, DC, Sundown, Digital Designs, they all look exactly the same because they're the same circuit. Yeah, exactly the same thing. What do you think of CCA wire? You might as well just go OFC. CCA is fine for under a certain amount of power, but why would you not go OFC? Just makes much more sense. Thank you to Oscar for the kind words. Okay, so let's crack on. We've got the clips off finally, and we sacrificed one Allen key to do so. Rest in peace, Allen key. So what I was trying to show you was, when I find the right camera again, what I was trying to show you is how to detect a shorted output section. So take a look here. So there was a question in the live chat that said, oh, what does it mean if the amplifier is constantly in protect? Well, this is probably what's happened. So you see, these are all our output FETs. They are most commonly the FETs, these things, which are after the rail caps. So in this style of board, it's laid out very simply. You have the power supply section. The rail caps are always by these, these are not FETs, these are rectifiers. Don't get the two confused. You will see a continuity on the multimeter if you try to measure between legs 1 and 3 on these. I don't even know if I can get my thing in here. There we go. So if you try and measure between the pins of the rectifiers, a lot of the time you will see continuity. On these ones you don't, but sometimes you will, because you're just measuring the coils of the transformers. So don't worry about these. These rectifiers very, very rarely die. Like literally super rare. Like out of every single amplifier I've ever repaired, I think I've seen these die one time. And that was in a jail. No, the jail order didn't even kill them. I think that was in the tar amps that killed them. So yeah, don't worry about these. These are the rectifiers, and they look different to FETs as well, because usually they don't have a metal back, or they have a different shape, or they have different markings on them, and they look like diodes. So don't worry about these. The ones that you're interested in checking for shorts are the ones which are after the rail caps, which are all of these ones along here, which in this case are 24N40F. So with these being MOSFETs, there shouldn't be any continuity between any of the legs. If there is, then it means that there is a short somewhere, which means that is the problem, and that's probably what killed the power supply section. In a rare case, the power supply might have died on its own accord, but it is very rare. You just took your glasses off, and now you put them on. So let's go ahead and check these for short. So we're going to put the multimeter on leg number 1 and number 3, and see what number we get on the screen of the multimeter. So over here we have a very high number, which is usually a good sign. And because this is a diode, if we swap these round, you'll notice the number will be different. See? So it depends which way round you have your probes. With output FETs, as you start repairing more amplifiers, you'll learn what these numbers mean. So generally, for an output FET, what you're doing is you're actually measuring the drive circuit here. So if the FET isn't shorted, you won't see a low number like 0 or 10 or 50 on the screen. If it's anything above like 200, then most of the time the FET is fine. And what you're actually seeing on the screen here is you're measuring the driver chip over here on the drive circuit, because that's what's driving the MOSFET. So if there's no short circuit over here, and you're seeing like 585 one way, and you flip these round, and then you should see a much higher number, like over 1,000, sometimes up to, in this case, 1,900 or so. That's good. So that little bank of FETs is most likely fine. So what we do is we just go along and continue checking these for short circuits first. So this generally looks okay. 1 and 3, no short circuit there. Okay. So that side looks fine. So we do the same for the other side. Very interesting. Okay, so you know how at the start of this live stream I said, so we've got a blown power supply, but it's very rare for the power supply to die of its own accord. Well, this is one of those situations. The output section, those FETs that we just measured on the output section, they don't have any short circuits. So generally, the output section, when it dies, it shorts the FETs, which then causes excessive load on the power supply, which kills the power supply. But in this case, the output section FETs, none of them are shorted. So that usually means the output section is fine. If the output section has any problems, because these FETs are driven so, like, they're so fussy about how they're driven, one tiny glitch in the output section will blow the FET. So the fact that none of the FETs are shorted most of the time means that section's okay. So the output section I think is probably fine. So the power supply section just died of its own accord, which is very random. Or did it? Because whilst we were checking those FETs, I don't know if anyone else noticed that, I saw something floating around inside here. So I'm going to take my tweezers and I'm going to give you my head cam again. And I don't know if you guys can see this. So we're going to go up in, where was it? Oh yes, here. Okay, I'm just going to try and see. I can't see my screen, so I can't see if you're seeing what I'm seeing. But I noticed this. I'm going to bring my hand behind it so it focuses on this. It's still trying to focus behind. Why is it trying to focus behind? There's like literally so much more stuff in front. Nope. It doesn't want to focus. But what this... I just dropped it. What this is a small stray strand of copper wire from the likes of a power cable or a speaker cable that has fallen inside of the amplifier and has been rattling around inside there. Now we found it just now on the output FETs, and it was actually between two FETs on the same bank. So that's unlikely to have caused any problems being there. But this little piece of wire probably didn't start off there. It's probably been floating around all around in here, and it most likely shorted something out in the power supply section, causing that to explode. Because, like I say, power supply sections generally don't die of their own accord. They're usually taken down by some external force, either the output section dying or something as simple as this tiny little piece of copper wire floating around inside. So I would say that is probably the cause of this problem here with the power supply. It's good news for the customer because it means a cheaper repair. The output sections can be more expensive to repair because they're more complex and they have much more issues that happen when it blows. So the fact that this just seems to have a blown power supply means that it's probably going to be a little cheaper for the customer than it would have been if it was a full rebuild. What's your opinion with 0.25 on with good electrical? So this is actually a video that I want to do at some point over the next few weeks. When you ask, will this amplifier be good at 0.5? Will this amplifier play okay at 0.25? What you guys need to understand is that it's okay. So yes, there are amplifiers that are built better than others, but for the most part, it's not down to the amplifier as to whether it will play okay at 0.5 or 0.25 even. It's generally nothing to do with the amplifier that allows it to play down that low. What gives certain systems the ability to play at 0.5 and even 0.25 is the efficiency and the inductance of the speakers being used and the enclosure, and to an extent the frequencies being played. It's not down to just the amplifier. You can take the cheapest build quality from China 1 ohm amplifier, and if you have extremely efficient speakers and subwoofers in an efficient enclosure, then you can run that amplifier at 0.5 all day long and it will never miss a beat. Never miss a beat like any different than it would have done on 1 ohm. However, you can have a very good amplifier like the DC5K here, and if you've got really shitty subwoofers that have terribly low inductance, or which have low motor force and that don't give much impedance rise to the amplifier, and you put it in a really tiny box that has a massive port and you're playing around the same range of frequencies as the port, which means that your impedance rise is super low as well, and you wire that to 0.5, then the amplifier is going to be pretty much playing at 0.5 reactive the whole time. And although these amplifiers are very good, they are not designed to be able to dissipate enough heat from these FETs to run 0.5 reactive all day long. So if you run an amplifier on an efficient setup where the impedance rise is greater than 1 ohm, the amplifier will not care about your wiring at 0.5, because as far as it's concerned, it's running within its rated specification that the manufacturer designed the board to do, a 1 ohm and above. However, if you're running an amplifier on a really shitty system, on a really shitty subwoofers or small box, large port, etc., where there's not much impedance rise, then the amplifier is going to be seeing a reactive load under 1 ohm, and therefore it's going to be putting it under more stress than the manufacturer intended and potentially fail the amplifier. So when someone asks, how good is this amp going to be at 0.5? To me, that's a stupid ass question, but it's a fair question because, you know, it's not necessarily the main thought process. People don't necessarily think about this, but, you know, certain amplifiers will be better than others, etc. I get that. But for the most part, the thing that allows 0.5 and 0.25 operation is the overall efficiency of the subwoofer system and the enclosure. If in my case, so I'm running Digital Design's Z4 subwoofers, this is the highest Gauss motor I have ever seen in my life. We measured it in the workshop. It was between 15 and 18,000 on the Gauss meter, if I remember correctly. I was very hungover that day. It was over 15,000 on the Gauss meter. I remember that for sure. We were like, what the fuck? It is an incredibly strong motor, horrifically strong, so much magnetic force in that motor. And what happens when you move a coil through a magnetic field? You create your own current, and that is inductance. That is, the amplifier sees that generated current by the coil and motor assembly as resistance. So as the coil of my Z4s moves in that stupidly strong magnetic field, it generates a high current that the amplifier sees as a high resistance. So with my Z4s, I could wire an amplifier down to 0.25, and it would probably be under less stress than if I wired some shitty crappy subs up on a 1 ohm load. It's not down to the amp, it's down to the subs and box that you'll use. No, I actually meant reactive 0.5. That's what I mean. If you've got a really shitty subwoofer setup where the subs are cheap and they have really weak motors and they really stiff spiders, really heavy coils, and you put it in a box that's on the small side and has a massive port, then your reactive load will be close to 0.5. If you've wired it on resistive to 0.5, then because there's barely any impedance rise, your reactive will also be close to 0.5. Whereas if you have an efficient setup like DDZ4s in a larger enclosure with a sensible sized port, then although your resistive load is 0.5, your reactive load will be like 3, 4, 5 ohms, whatever, depends on the frequency you're playing. What's the BL factor of the Z4s? Good question, Nicholas. I can actually find that out because I'll be able to run it on my DATs, but Digital Designs, they don't provide those specifications. Because the Zs are custom built to the customer specification, there's no point giving a list of TS parameters because every single one will be completely different. So these Z4 motors, I think they're limited to 20 or 30 in the world being made. I've got numbers 13 and 15. So yeah, I could run the DATs and see what the BL product is on that. The only annoying thing is I'd have to remove them from the enclosure, and doing that takes about 3 hours because you have to unbolt the motors to get them out of the enclosure. So I'll do it at some point, but it won't be for a long time. Because I forgot to actually run them on, I didn't think about that, running them on the DATs before I put them in. And also another reason that I didn't run them on the DATs, because they're brand new. So when they're brand new, all the ratings will be fucked because they're super stiff and they're not broken in yet. So once they've been broken in for a while and I'm doing some experiments, maybe I want to respray the box, maybe I want to do something to work on the van, I'll take the woofers out and then I'll run them on the DATs once they've been broken in, and you can see the horrifically high BL product. Right, anyway, let's crack on with this. So I actually need to now go ahead and dismantle, take the amplifier out of the case to get to the power supply. Now, I can already tell that we're going to need to replace the drivers here as well. So if we take a look here, I don't know if I'll be able to zoom in enough. Actually, my zoom in camera is not actually turned on. Let me turn my zoom in camera on for you guys. Let's see if we can get that up and running. This always happens. One sec. Go ahead and reset this shit. Oh man. Why? It looks like we're on Jupiter. Oh no, now it looks like we're on, I don't know, some green planet. Okay, let me try and fix that. There we go. All it needs is just unplugging the HDMI cable and plugging it back in again. Have you tried unplugging it back in again? Why yes, it actually worked. Okay. So yeah, I can already tell that we're going to need to replace the drivers in this amplifier, because if we take a look at, where are we? Here we go. This one over here. Here. Ooh, damn. She stank. Yep, so a visual inspection goes a long way. This is one of the driver transistors that drives the MOSFET gate for the power supply FETs. As you can see, she ain't looking too pretty. Jim, yeah man, yeah, the Jim's B2 mono is up and running. Full repair. I was talking to Giant about that one the other day. Here we go, here's Jim's B2 mono. Yeah, she works perfectly. I had it running for about 2.5 hours yesterday, running some pretty decent loads into my static, my dummies here, and yeah, she seems happy. I don't really know why it died again. Very confusing, but seems very, very happy here. So yeah, give it another go. And there's no charge on that one either. There's no charge on that repair. That's for a free repair for you there. So yeah, I'll shoot that back out and then give it a go and let me know how it goes. So yeah, okay, cool. Let's start taking this thing apart and getting those drivers and stanky FETs out. If anyone else has got any other questions, because whilst I do this dismantling part, this bit takes a little while. So guys, ask me some questions and shit. What do you want to know? What do you want to talk about? We don't have to talk about. We don't have to talk about audio. We can talk about anything. Ask me some random questions about anything, about life. Slam them in there. I don't care. Why don't they use a proper MOSFET driving ICs? Because these circuit designs are so old that when this board was designed, those MOSFET drive ICs didn't really exist. Or if they did, they were too expensive and they couldn't be bothered to implement them into this circuit. This actual circuit design is like 15, 20 years old or so, maybe more. So all that happens is that these factories they don't actually bother trying to come up with a new design for the circuit. They just look at this old design and say, well, this one worked fine, let's make it bigger and just whack it in, because it's cheaper to do that than it is to employ somebody to actually redesign the circuit or take the time to redesign the circuit. So that's why all the Brazilian amplifiers all are using the modern technology, or they're all using like 4227s or whatever they're using proper MOSFET drive ICs, and they're using PICs, and they're using dead time control and all sorts of other fancy bits and pieces, because they are actually designed with modern components in mind. Whereas all of these things, these are all flipping 20 years old stuff. What is the meaning of life? The meaning of life is 160 dBs. 160 dBs or bust, or die trying. I don't know. For me, the meaning of life is just fucking live it, man. Enjoy yourself. Do not do shit that doesn't make you happy. If you're in a job that you fucking hate, then obviously you gotta make ends meet. But get out of that shit as quick as you can. Find something that you love doing. Find something that you absolutely love doing, and try and make that. Try and make money from that. Try and think of what do you love doing. I loved audio. I love problem solving. I've taken shit apart, finding out how it works, putting it back together again. So how the hell can I make a living off of that? Amplifier repair is never gonna make me a millionaire. I'm never gonna be some rich son of a bitch. I'll be like, hopefully like comfortable in life, be able to afford the holidays, be able to buy my kids Christmas presents and whatnot. I'm never gonna be mega rich. And I'm cool with that, because I'm fucking happy doing what I'm doing. Don't chase a paycheck, man. Do what you love doing. Make sure that it's enough for you to live comfortably, and be rich in happiness and free time. Be rich in what you do, not monetary stuff. Does box rise also rises on higher power? See, I told you my phone would keep going off. All right, let's get back to some of these questions. Does box rise also rise on higher power? Yeah, it can do. So box rise, impedance rise is as a result of the coil moving in the gap. So as you add more power, the coil obviously will move further. But there's also something else that happens as you add more power. So it's all very system dependent. There's no kind of like easy yes or no answer. Will it rise more as you add more power? I've seen systems that as you run a low volume, the impedance rise is like maybe, I don't know, say 2.8, but then when you flat out, it's then 2.3. But I've also seen systems where on low volume the impedance rise is like 2.2, and then when you flat out, it's 2.8. So it is all completely system dependent. It can go either way. Hello Sam, James here. I was the man, came round your house, but actually got the wrong house down that sat nav. But dude, I'll get that answer you one day. Huh? Actually got the wrong house down that sat nav, but dude, I will get that answer for you. What answer? Sam, I had a repair the other day on a CT Sounds T2500 and it had just one bank of power supply FETs out, just 4. One of the drivers let go and blew just those. Usually they all go. Yeah, oh, usually, so power supplies, yeah. Usually the power supply, if one set of FETs go, then it takes most of the rest of them out, because when a FET short circuits, it sends the 12 volts from the battery down the drive line to the drivers, which then in turn, because the drivers are kind of all connected together, will then send the 12 volts to the other MOSFETs, which turns the other MOSFETs gates on fully, which then blows the other MOSFETs. But Josh Hansen, I've also noticed that some amplifiers, when some power supply FETs blow, the others continue to work, and even in some cases, the amplifier still runs. Even with one bank of power supply FETs basically smoking up, the amplifier still runs fine. And I think those amplifiers must have some kind of diode in place in the drive circuit to prevent the 12 volts going back to the other FETs, which is pretty nice because it means that you have to replace less when the amplifier goes down. I have seen that before. I've seen it before on B2 audio amplifiers. But most of these, like for example this amplifier, I don't believe has that kind of circuit in place, because the power supply here, we lost all of them. So what I'm doing now is I'm actually, because these output MOSFETs, they are on the heatsink with this kind of really spongy yellow insulation pad, and it actually sticks, it actually goes sticky. So what happens is the FETs are now kind of stuck to this yellow spongy pad, and if you try and pry them away too hard, then you actually rip the pad in half, and then you can't use it anymore because it's no longer thick enough for the voltage that's on the FETs to prevent the voltage from arcing through to the case. So I'm just very gently prying it off, and what I'm trying to do is actually get the yellow foam to come away from the heatsink rather than the FET. So as you can see, if we go to this one here, so I'm just pulling that away from the actual heatsink itself, not from the FET, because it sticks to the back of the FET more than it does the heatsink. On one of these over here, it actually screwed up, and I'm not sure if you can see this, but yeah, there's some of this yellow stuff stuck to the back of the FET, and so it's kind of torn it a little bit there. So I may have to replace that one, but we'll see how that goes. So yeah, the others I'm just trying to get them away from the heatsink like this, but staying on the back of the FET, so it doesn't risk ripping that nice yellow spongy material. That's actually very interesting, nice material. It's a weird kind of foamy thing. It's kind of nice actually, as a material to feel, and it's a kind of rubbery, sticky foam kind of stuff. Oh damn, that one went in hard. Look at that. Look, there's pretty much the yellow stuff is all the way stuck to the back of that regulator. But fortunately, the regulators are a little bit less important, and I've got loads and loads of spare bits of foam for these regulators, so that's not a problem. Yeah, I'll probably go ahead and replace that whole piece of the yellow foam there. So yeah, I'm just prying all these away so we can slide the case, the board out of the case here. We need to pull the rectifiers away from the edge as well. Now, you don't want to do this too much. So obviously all these parts that are still working fine, the output FETs and the rectifiers, you don't want to pull them too far away, because obviously every time that you bend the legs, you weaken them. So if you're bending them back and forth, back and forth, back and forth, then they're going to snap off eventually. So obviously this amplifier doesn't look like it's ever been repaired before. So they've gone forward one time now. So I only want to really put them back one time once we finish the repair. So we'll keep them in this position. We don't want to bend them any more than necessary, because it just weakens the legs. And as you weaken the legs, you actually also limit the amount of current that can pass through them. You increase the resistance of the legs the weaker they get from wobbling them back and forth like that. Okay, cool. I think we should be good. This should slide out nice and easy now. Let's have a look on the live chat just real quick. What did you eat for dinner? Dinner time hasn't come yet, but I had a lasagna for breakfast, if that's even a breakfast food. What got you into car audio? I got super into audio. My mother gave, when I was about 9 or 10 years old, my mother gave me a retro old school Rotel hi-fi system, and I loved turning the bass knob up and watching the speakers move, watching the excursion. And I guess I found like really awesome videos of car audio systems on YouTube, because, you know, what was it? I think it was Realm of Excursion back then. I was watching videos on Realm of Excursion and YouTube of all sorts, and I was like, oh damn, this is epic, look at that speaker going crazy. I was like, this is sick, this is what I want to do. I think that's how I got into car audio. New driver ICs are quite cool. They can detect MOSFET desaturation, overcurrent, and so much stuff. That's fucking cool. That's the sort of cool information that I'm going to be needing to research when it comes to designing my own amplifier that I'm going to do at some point. Twisted Sounds 3.5K goes in Protect only when you have the volume turned up. I was the only one out of the 3 doing it. Any thoughts on where to look first? That potentially sounds like a snapped or like a weak leg on the rectifiers perhaps. So what's happening is, as you turn the volume up, the output section is demanding current from the rail voltages, but it's unable to obtain rail current from the power supply because the rectifier legs are snapped. So what I would do is I would take the whole board out of the case like this and check for like legs that are snapped off anywhere, check for all sorts of bits and pieces. Also check that none of the inductors here are wobbly or loose or look like they're shorted out. Those kinds of issues can be a pain in the arse, and what you have to do is you have to take like a known working amplifier and compare it to the one that you've got that's causing the issues and see where the differences are. Here she comes. Nice and easy. Can you tell us how to properly set the bias in Class AB amps? I have an old school Zapco that needs an adjustment. Yeah, what you need to do is, so the bias you can set to different points depending on what you're going to be using the amplifier to run, and also how much power you need to get from it. So with a Class AB amplifier, the best way to set the bias is to, you need an hang on a minute. Where's the, something is stopping this from coming out fully. Oh, there's a screw here. Yeah, one sec. I need to desolder this ground wire. Yeah, with the bias, you need to take on an oscilloscope for your Class AB amplifier, so you can probe the audio output wave from the speaker terminals. And you need obviously an input, a frequency generator that can go up to 20 kilohertz, and you need, wait a minute,